Hello, everyone. Welcome to the Energy Conservatory webinar on Field Calibration Check for our pressure and flow gauges. We hope that this is going to be something that will be useful for you, and we're going to provide you with useful information on how to do a calibration check in the field at your facility. And we'll also describe what the difference is with the factory calibration and what you can expect with that. So, on to our session today. We're going to cover a few things regarding terminology. What is the stated accuracy of our digital gauge? How often should a digital gauge be calibrated? What is involved with factory calibration? What's involved with field calibration check and how do you perform that? And how do you do a quick check to identify large problems with the digital gauge? And at the end, we'll cover briefly how to do a field check of your fans. My name is Frank Spivak with the Energy Conservatory, and later on in the presentation, we will have Paul Morin. So first off, let's deal with a little bit of terminology so everybody understands what we mean by the various phrases that you'll hear today. So the first one, accuracy. Accuracy. The degree of conformity of an indicated value to an accepted standard value or true value. So when we take one item and we compare it to something that we know really is accurate, how well does it meet that? How well is the conformity of that to the true value? Now, calibration is when we correct or determine what the error is of an existing scale compared to readings of another device. So when we know something is 100 pascals, if our instrument is reading 90 pascals, we know that it's 10 pascals off, and that's a calibration or a correction of an existing scale. So factory calibration versus field calibration. Factory is that we adjust all of the internal workings of the gauge to bring it into agreement with the standard. And we'll show you what that means. Now, the field calibration check is when you're comparing one gauge to another, but no adjustments are actually made. So the ability to bring a gauge that's out of calibration can only be done here at the factory, because that's all done with a computer calibration algorithm. So in ResNet Chapter 8 and now the existing standard of 380, we talk a little bit about the differences of what that means. Blow door and associated pressure testing instruments shall be tested annually for calibration by the HERS rating provider or certified rater. The provider shall use a standard for testing and calibration provided by the equipment manufacturer. So basically, under ResNet Chapter 8, we have a procedure to do a calibration check, and ResNet is saying that the provider is allowed to use that procedure in order to check the equipment of all the various testers and raters that are out there. In Standard 380, the phrasing is the equipment listed in the section shall be tested annually for calibration using the manufacturer's recommended calibration procedure. So we were recently asked about this. Our calibration recommendation is for every 2 years to be done at TEC. But we do provide a calibration check procedure, and that can be done annually. And that's what that's referring to. Now, on the right-hand side of your screen, there is a box which says Downloads. You can click and highlight Field Calibration Check Procedure. It's a PDF document, and download that, and you will have our latest version of the calibration check procedure. Now, ResNet also talks about what the instrument should be capable of. So pressure gauges shall measure pressure differences with a resolution of 0.1 Pascal and have an accuracy of plus or minus 1% or half a Pascal, whichever is greater. The new standard says that the device can measure pressure difference with an accuracy equal to plus or minus 1% or 0.25 pascals, whichever is greater. So in the new standard, it's actually a little bit tighter than the previous standard. So any instrument that's used for measuring pressure has to meet this new standard 380 criteria. The specs of the DG700 are that we have a pressure range of 1250 pascals, both negative and positive. So when you're doing a pressurization or depressurization, the range has a maximum of 1250 in either direction, and has a display resolution of 0.1. The accuracy statement for our DG700 is 1% of pressure reading or 0.15 pascals. So as a standard, our instrument will easily meet and exceed the BPI requirements. So how often should it be factory calibrated? Originally, when we started building both the DG2 and 3 and DG700s, we believed that a 1-year calibration interval was acceptable. And over time, once the DG700 was out and we were able to keep track of all of the calibrations over time, we determined that when we looked at all these gauges, and we had roughly 10,000 gauges that had come in over a number of years for recalibration, and we looked at when was the time that it was last calibrated and how much time is it now. So from that, we were able to determine that interval. And we decided that since 99% of all of the gauges retained their calibration at 24 months, that we changed our calibration interval to 2 years. So a factory calibration is 2 years. So where did all this information come from? So here you can see in this chart, and you can see the two different colors. One is actually channel A and one is channel B. So on the far left-hand side of the chart, you can see that everything is right very close to zero. And over time, and this is in the number of days continuing from right to left, all the way out to 3,000 days, you can see that the pressure channels start to move away from zero, and for the most part, they tend to go in the same direction. And you'll also see that both channel A and channel B will also move together. So they will track with the, instead of a negative accuracy, a positive accuracy, you can see that they track all the way from right to left. You can see them all moving in an upward direction. So the vertical line shows the 2-year period, and you can see the yellow lines represent the 1% of accuracy. So when we get to 2 years, we start to see more and more data points starting to exceed the 1%. Certainly when we get out to 3 years, that it gets to be more. 4 and 5 years tends to be very much scattered and definitely outside of our calibration range. So we want to be on the safe side with making sure that everyone's instrument is sufficient and accurate for all of the tests that they're performing. So that's why we've limited it to 2 years. So what have we learned with some of this data? We know that both sensors will generally drift in the same direction and generally by the same amount. So it's not sufficient enough to just do a comparison of one channel to the next to see, well, is channel A that much different than channel B? Because what we know from our experience is that they will both be off by the same amount. So it's not likely that you'll be able to determine much just by doing a comparison from channel A to channel B. After 2 years, we do see a significant number of gauges that are outside of our specification. And certainly there are some gauges that are within specs at a very long period. When you look at that graph, there are gauges that have been out there for 4, 5, 6 years and will still meet that accuracy of 1%. The difficulty is we never know which gauge that is. So it's always a wise choice to be able to do the periodic check to see where your gauge is. And if you're able to compare that to a recently calibrated gauge, and that's the best standard. Paul will talk about all those procedures next. So we recommend once every 2 years. The cost is $100 and is usually completed in about 2 or 3 days. And then the $100 includes the cost of return shipment. There are both before and after certificates included, meaning we test your instrument as we receive it, then we perform a recalibration on it and provide you with another certificate that gives you all of the information. This is our factory calibration setup. So on the left-hand side, you can see a Menser device. That is a calibration standard. You can see the pressure tube attached to the right-hand side. So we're applying pressure. We're also applying that same pressure to the gauge that you can see on the right-hand side. And we compare the Menser calibration device on the left with the values of the gauge on the right. Now we don't do it by eye, we do it through the computer, and you can see the computer connection right up on top. Now I apologize for the fuzziness of this image, but the intent of this is to show you that calibration of gauge serial number 15604 has channel A actually is really quite good, but channel B doesn't have any values. So what that means to us is that the pressure sensor on channel B has we sometimes refer to it as being blown or is just broken. So when we see that, we have to go in and change that. So the sensor must be replaced. There is another issue that can affect sensors that has to do with the zero offset problem. And what you'll see, and this is one of those cases where you might be able to compare one sensor on channel A to channel B, and if you see that they are roughly 50% off from each other, then and it's usually 50% low. It's rarely that it's 50% high. So if you see one that's reading 100 and another one that's reading 50, chances are the sensor that's reading 50 has this zero offset problem, and that also needs to be replaced. And if you have it within 2 years of purchase, then we will certainly replace that under warranty. So when we replace a bad sensor, you can see on the left-hand side the pressure sensor of the DG3, which is considerably larger than the pressure sensor of the DG700 on the right-hand side. You can see in the center towards the top, that is a AA battery, so that gives you an idea of the relative size that we're trying to deal with here when we're talking about pressure sensors, both the DG3 and the DG700. Now, let's get back to serial number 15604. We do a leakage test to make sure that all of the hoses are connected and the zero valves are functioning. Then we perform the calibration check. Now on the left-hand side, you can see this is the as found data. So this is channel A and channel B. You can see the channel B now has values because there's a sensor there, and that at 1220 pascals positive, that we had an error of minus 1.4. Now this is very characteristic of a brand new sensor being installed into the gauge and has not yet been calibrated. So on the right hand side, you can see that this is the as left or after adjustment. And now channel B shows all of the values at 0 or plus or minus 0.1. This is, for us, this is what we would consider like a perfect calibration. So there's the as before, as found, the before adjustment. There's the numbers after adjustment. And this is the calibration certificate. It's a little blurry, can't see it too much, but every person gets a calibration certificate with their gauge new. And when you have it calibrated, you will get 2 sheets of paper. The one on the left is as found, and the one on the right is after calibration. We've also been asked occasionally, what is the accuracy of the DG700? And at the bottom of the digital gauge calibration certificate, there is a statement which says that the instrument has been tested to an accuracy of plus or minus 1%, plus or minus 0.15 pascals. So you can always go to your calibration certificate to find out that information. So next, Paul is going to present on how to do a field calibration check. Please continue to ask your questions and we'll answer them as we get finished with Paul's presentation. And then after Paul's presentation, we'll also talk a little bit about how to do fan checks.
In this section, we'll be talking about a field calibration check. And this is a way where you can check your gauges against a reference standard and see if a gauge needs to be sent in for calibration. And when we're talking about a reference standard, that's a gauge that you use, has been calibrated within the last 6 months and stays in the office and is used just for this purpose of checking this standard against other gauges. So if you have a lot of different people in the field that have multiple gauges and it gives you flexibility for them to come in at their convenience and have the check done. Another option, if you only have a couple of people with gauges or just one person with a couple of gauges, is send one of them in for calibration and then use that as a standard and check it against another gauge before it gets out in the field again. So these two methods give you a lot of flexibility on using a gauge that you know is within calibration spec to check another gauge to see how that one's doing. And you're going to use a syringe to induce a pressure and do the check at a number of different pressures, but you want to make sure not to damage the sensor with that syringe. Larger syringes can easily overpressurize the gauge, and then you're going to have to send it in for calibration and repair. So the way to make sure you're not damaging the pressure is if you've got an old magnehelic gauge around, or if you could certainly buy a new one also, and you can use that as a buffer. It's got a bladder in there that'll protect your gauge from overpressurization. One of the downsides of magnehelic gauges is over time they get leaky and they won't hold pressure. So then you can apply the pressure from a syringe, but you won't be able to hold pressure. So that method has a downside. So we came up with a new method that uses a 1 milliliter syringe and 30 feet of tubing. It's important to have that 30 feet of tubing on there, so that acts as the buffer, so you don't overpressurize with that small syringe. And the DG700, the maximum pressure is 1,200. About 1,200 pascals, and we're only testing at 500. So, if you're careful, you shouldn't have to worry about running over 500 pascals of pressure. So this is a basic field calibration check that's been in our manual for years and years, and it shows using the Magnehelic gauge in a syringe. We've typically used 12 cc, 12 cubic centimeter syringe, or you could use one even larger than that because you've got the Magnehelic gauge for a buffer, and connect it up. You only need to connect up to one of the channels of the standard, and then both of the channels of the gauge being tested. And you're just checking to make sure that they're all reading within 1% of each other. So this is a picture of using a DG1000 for a standard and comparing 3 other gauges against that. So we've got the 1 milliliter syringe, the Magnehelic gauge, and total of 4 gauges. And this is showing 30 feet of tubing in a 1 milliliter syringe. So now we're using a much smaller syringe, and we're not using that Magnehelic gauge as a buffer. And this is, the reason we kind of switched to that is you don't have to have a mag gauge around, and this is also a closed system. So you don't have to worry about the pressures dropping. One other thing that's interesting about this process is when you have a closed system like this, it's really susceptible to pressure changes. So if you wrap your hands around that tubing, for example, you'll see those pressures go way down. So you need to be cognizant of that, and you'll want to let the tubes sit for a while, and set everything up on a table and let it sit for a while for the tubing to adjust to the pressure or the temperature on that table in that location, and let it sit for a while so the pressures will stabilize. So this is showing that procedure again with 4 gauges total. We're using the DG1000 as a master, and we're connecting to reference with on one of those channels, and we're comparing that with the 3 other DG700s. So the instructions on the website will include this calibration check form for your documentation. So you record the serial numbers and the date, the technician whose gauge that is, and the last factory calibration. And that factory calibration date will be on the sticker on the back of the gauge. So you're documenting that date of last calibration, as well as today's date when you're doing the field calibration check. A preferred method that we're strongly suggesting is to use the TechLog 3 software to do this check. So then you've got documentation instead of having a paper documentation. You've got a live graph with numbers, and you can set an averaging period and get rock solid data and have very well documented proof that you did the test. And some advantages of that is the software recognizes the serial numbers, and you have to have the serial number right because there's a chip in the gauges that the software recognizes, and it brings in that information, and it also brings in the last date of factory calibration. So you're documenting that for sure the gauge that you're comparing them against has been recently calibrated. It's been calibrated within the last 6 months, and you've got documentation of that. And also, you can't mistype or miswrite down the serial number of the other gauges that you're doing the comparison against, because that information is all brought in directly from the chip on the gauges. And the software graphs the entire procedure, so you can see visually what pressures that was tested against. And once you achieve that target pressure by moving the syringe, pulling out the syringe, you can create a 10-second averaging period. That averaging period is adjustable, but I think a 10-second average is good enough. And then you can view the stats for each period of record, and that's where you've got the comparison. You can see the 10-second average for each gauge during that period, and make sure it's within 1% of the requirement. If it's outside of 1%, then it will need to be sent in for calibration. Another big advantage is that the gauges will all auto zero at the same time, and there is a slight pressure drop when it auto zeros, and that's one of the big advantages. If you turn on all the gauges at the same time, they'll auto zero at approximately the same time. But if you're playing around with the syringe trying to hit that target pressure and it auto zeros, then you're kind of starting all over and adjusting the pressure again. But you can set the auto zero period to 1 minute in the software, and that gives you a chance to get your pressure set before the gauge auto zeros. And that provides your record. That tech log file is your record, and so you don't need a paper trail. You'll have that documentation that's rock solid. So the procedure is you will have to make a connection. In order to use the software, you have to make a connection between the gauges and your computer. If you're using a DG700, you can use a serial to USB adapter, and that adapter will require drivers. Any of those cables you're using to connect the DG700 to a computer come with drivers and require that driver to be installed. The micro USB to USB cable, if you've got a gauge that's newer than 2009, then that micro USB cable came with it, and the drivers for that are on our website. The drivers for the DG500, DG700, and that's another way. That cable's 15 feet long, so that's plenty for what you need for this test, and you can use that method. And another option is a Wi-Fi link. And if you've got a Wi-Fi link for DG700, and if you're using more than one gauge connected that way via Wi-Fi, you'll need to put it in router mode. So you'll need a router, and you'll need to connect all of your gauges to that router, and then the router to the computer, and allows you to do that wirelessly. With the DG1000, instead of a macro USB, it has a mini USB, which is slightly different, and that requires that the drivers be on your computer also. So if you get a new computer, you got to make sure the drivers follow you, and then that has Wi-Fi built in. So So that's the easiest way to make that connection during the test is through Wi-Fi. So this is showing a variety of methods. In this case, the DG1000 is connecting via Wi-Fi. Two of the gauges are newer gauges, so they can use that micro USB to USB adapter. And then you'll notice I'm using a USB hub. So these three gauges, the two using the micro and the one using the serial, and then the serial to USB adapter, are plugged into that hub, and then I've just got one cable from that hub going into the computer. And that hub doesn't need any special drivers, it just works. Or at least this one did. Maybe the driver was built into it if it requires a driver, but it was just plug and play. So you'll need a serial cable, and that cable is an extension cable, so it's male on one end and female on the other, and it's a straight through cable. There are a number of different types of serial cables, so you'll need a extension cable that's wired straight through, and then you'll need a serial to USB adapter, and it's this serial to USB adapter that comes with a driver that'll need to be installed on your computer for that to work. So that's another option, and TechLog recognizes any combination of these cables or using Wi-Fi. Another option, if you've got multiple, if you've got 4 DG700s, for example, and you're using the serial cables on each of them, you can buy a serial to USB hub. And then that hub will come with its own drivers. That allows you to plug in multiple serial cables to a hub and then go to the computer that way. So lots of options on making the connections to the computer. And this is showing the other option where you're using Wi-Fi from all of the gauges, and then sitting on top of the computer here is just a small TP-Link is the name of this router. It's just a small router. It's less than $40, and it's got a battery in it, so that's convenient. You recharge it like you would a phone, but that's a nice option for a small, fits in your pocket kind of router that doesn't need to be plugged in except to recharge it. So there's some options for connecting the gauge to your computer. So now we're going to use a demo using our TechLog 3 software that it's a free download from our website, and you can check on our website. We did a much more detailed demo of this that you can follow that teaches a little bit more about using TechLog, but we're just going to kind of give you just a general idea of the process of using TechLog. So this is a screen that comes up when you launch TechLog, and first we'll go up to configuration settings up here, and I'm going to delete these serial numbers, and then I'm going to click on this button called Scan for Ports and Devices, and now it'll do a scan of all connections, whether it's a cable connection or a Wi-Fi connection, and it found the DG700 along with its serial number. So it pulled up the wired connection first, and then it pulled up the Wi-Fi connection. So you made connection with our two gauges. Now up in the serial number box, I'm going to double click, and it's pulling up our DG1000 as our standard. We labeled it as standard, and our DG700 is our test gauge. We labeled it as test gauge. And then I'm going to click on the view and edit channel settings, and you can see the two gauges are up here. We turned off one channel, We labeled it standard B, so that's our standard gauge channel B, and we left it as a pressure, and we can choose what colors we want here. We want it to graph. And then I'm going to click on the DG700 tab on that serial number, so it says across top DG700 along with its serial number and its name. And we left that in pressure. We could choose between interior pressure, envelope pressure, Model 3 fan flow, duct blaster flow. We left it at the default pressure, changed the colors, and gave them labels. So click OK there. I'm going to click OK here and go to recording, start recording. Now it's going to scan for the devices, and now it's going to do the handshake with the devices it's finding, and it'll start sending data. And once it starts sending data, then if you push the buttons on the gauge, they're inactive. Now the computer has control of the gauge. You don't want to have control at both locations, or things really get confusing. So I'm going to call this test. Let's call it 11 for the heck of it. And we'll save that to our desktop. And now I am going to connect the tubing to the reference taps on the DG1000, and we've got T connections, so we've got 3 tubes we can connect. We've got one to the reference on channel B on the DG1000, and then we've got the other tubes going to the reference on both channel A and channel B on the test gauge. So now we can see we're down around 0. I'm going to push in the syringe all the way on the plunger all the way on the syringe, and then connect it to the tubing. And you can see when I connect it to the tubing, it goes negative, and then I am going to pull out to get us up to positive 500. So you can see the numbers changing over here. I'm going to go up to positive, and I want to be 500 plus or minus 30, you know, just in that general range here. So we can see all 3 have gone up, and they're in that range. And I'm just going to make a short period of record, a 10-second period of record here, and then I'm going to click in that box, and I'm going to create a period of record. And I don't want to include it in an air tightness test. We're not doing an air tightness test. And that one's 500 pascals. I'll give it a label. And then I'm going to push in the syringe to get it down to 50. So you can watch our numbers go, or you can watch the graph go. And we want to be down to 50 pascals. There we go. And then we'll let it even out. And we'll click on this, and clicking on this white box there, we're going to make a 10-second period of record by pulling it across, and then I'm going to create period of record. So I right-clicked in there, call that 50 pascals. Okay, and now I'm going to switch the tubes on the test gauge from reference to input. So switch those 2 from reference to input, and I'm going to pull out to get to, I didn't change my reference on the standard gauge, so I'm still looking for a positive 500 on that one, but it will be negative 500 on the other. We just need to be within 30 pascals. So now I'm going to click on this box up here, the second box, here. I clicked on that, and now I'm clicking and dragging to create that period of record. And then to make it bigger or smaller, if you hover over it, you'll get an arrow, and you can make that smaller so we can go to 10 seconds like the rest of them. Then I'm going to right click inside that white box, create a period of record. We'll call it -500. Okay, and then I'm going to push it in to get us to 50. Seconds there, so I'll grab the arrow, move it to 10 seconds there, right click inside it, create period of record, and we're at -50 there. Okay, so that's our quick overview of the test. Then I'm going to go up to recording. Oh, one other thing I'll show you before I do that is if we go up to view, we can choose DAB DG information, so view DAB data acquisition box DG information, and that'll show our serial numbers and our last calibration dates. So then that way we have a documentation that our standard gauge was calibrated within the last 6 months. So that's great documentation for that. You've got proof, and this becomes your document. So I'm going to go to recording, stop recording. This will stop our data capture, continue, yes. Would you like to load the file you just created? Yes. So now we can look at our data. So I'm going to click in that green box, the first one, the 500 Pascal one. I'm going to click in that, it turns white, and then I'm going to right click and choose show stats. Now we can look at our information and see if we're at 500 pascals, we want to be within 5 pascals, and we're within less than 1 pascal. So we're easily within 5 pascals difference from the standard gauge to those other 2 channels. So that one's good. We'll look at so I'm going to click inside that green box at +50, show stats. Now we're at 50, we want to be within 0.5, and we're within 0.01, 0.02, so we're really good on that one also. And then -500, show stats. We need to be within 5, and we're within less than 1. And then our -50, so I clicked in it, it turns white. Right click, show stats. 50 pascals, we're within tenths of a pascal again, and we need to be within 0.5. So we are looking good. So that's using TechLog, and this can be your documentation, your data file. So now I'm going to switch back to our PowerPoint. And another thing you can do with this setup is compare the channel of one gauge to another on a single gauge. So with this, we're looking for just large errors in our gauge. So if one of the channels is way off, and we suspect the problem is our gauge, we've done some troubleshooting and we think the problem is the gauge, this is a quick check you can do. If you've got the syringe and 30 feet of tubing, you can use that same procedure. Pull out the plunger till you get to 100 pascals, and they should be within 1 pascal of each other. Another thing you can do is use your fan, either blower or duct blaster fan, uncap it, run the tubing from the tap on the fan to a T and connect it to input and reference your gauge, and turn on, leave it in pressure mode, PR, so you're reading pascals on both channels, and turn up that fan. It can be just sitting in the middle of the floor, it doesn't need to be connected up to anything, and run it up to 100 pascals, and channel A and channel B should be within 1 pascal of each other. So that would be 1%. And it doesn't say your gauge is within calibration. It's not a calibration check, but it's just a quick check to see if there's a large error on one of your channels.
Hopefully that information was useful for you. Now we'll go on and do a few things with the fans, but we wanted to address something that we did have somebody ask us about this before we started doing when we announced we were doing this webinar. And we were asked, why are we doing this? And isn't the Energy Conservatory basically losing money by offering the field calibration information? And the truthful answer is yes. It means that we're not calibrating as many gauges as we might. But for us, we're trying to provide this information to you, our customers, as a service, so that you can believe in the integrity and accuracy of your gauges as you use them from week to week and month to month and year to year. So we encourage you to provide, to do your own calibration checks periodically. And it also helps you as long as you keep a track of it. If you keep records of when you perform this calibration check, that should you start to see a change where your instrument is moving out of calibration, you'll know that now's the time I need to do something with it. And if it's not moving, then you have a higher confidence in what you're doing out in the field, and making sure that your instrument is working properly. We get a number of questions throughout the day for technical support where someone doesn't think that the reading that they're seeing on their gauge is correct. And we walk through the general procedures of looking at the gauge, checking it against a fan, like the quick check that Paul was talking about, and determining, is it actually reading numbers, and are both channels reading similar to one another? Most of the time, and I would have to say almost all the time, the gauge or the fan are working properly, and it's just that the situation that the user is being confronted with at the house is that there are issues there. Sometimes it's not knowing that a whole large section of ductwork is not connected, and when you see a number that's really crazy, the first reaction might be, the gauge or the fan might be out. And walking through all of that, getting the confidence that yes, the gauge and the fan are working properly, you just walked into a house that has some major issues that need to get addressed. So moving on to the fans and the flow sensors. The picture here that you see is of the Model 3 flow sensor. And if you're not fully aware of it, it is a plastic molded device that has two parts that are glued, sonically welded together to create a pressure sensor area behind the plastic, but is connected to the atmosphere by the hole that you see on the side of the flow pressure sensor. The screws that you see placed, the three placements, the three screws that you see there, those are screws to adjust how far away from the motor the pressure sensor is. So you're able to adjust it up and down to move the pressure sensor either closer or further away from the fan in order to get the flow sensor in its proper location. I'll show you the measurement process in a moment. So one of the things we want to do is we want to test the integrity of that Model 3 flow sensor. So the process is where you want to tape over the holes of the pressure sensor. So hopefully you can see that there's a small piece of masking tape over one of the holes, and there are 4 holes around the flow sensor. Now, one of the things that we do not recommend is not to do this test with a duct blaster fan. The duct blaster fan has a very different pressure sensor. It's a stainless steel tube, and it is extremely difficult to accurately put tape over those holes, and much less get that tape back off again. So we do not recommend doing this test with the duct blaster. This is only for the blower door. So in the process here, you want to connect the same syringe that Paul was talking about. You want to pressurize the syringe as you connect it up to the fan. So you can see that there's the red hose is teed to the DG700 and goes to the Model 3 fan up at the top. And so we pressurize by pressing down on the plunger of the syringe, and the intention is to try and maintain 100 pascals. And as long as you can maintain that by slowly and continuously pushing that plunger in, and you can do that for about 20 seconds, the sensor and the tubing connections are good. Now, what this should tell you is that there are some what we would call micro leaks in all the different connections. We have a lot of different T's that go from the pressure connection in the electrical box of the fan and through to the flow sensor itself. So very small, minute leaks are okay, and you'll experience that by doing this test. If, on the other hand, you try and push the plunger down for 100 and you keep doing it and you run out of room on your plunger and you still haven't reached 10 or 15 seconds, then chances are the flow sensor has a crack in it and will need to be replaced. Flow sensor position is also important, and this is what affects calibration. So what we want to do is measure the distance between the flow sensor and a reference point, and the reference point is the outside perimeter of the fan housing. Now, the fan motor is able to move in and out of the fan housing. We try to keep it locked down as best as we can, and but occasionally, if the fan is dropped either on its face or on its back, then it has might have a chance of moving the position of the motor forward to backward. So we want to make sure that that's good. So basically, taking a flat edge, and in this case we're just using a 24-inch level. The 24-inch level goes across the fan housing, and from the bottom of that level to the top of the flow sensor should be roughly 3/8 of an inch. and plus or minus an eighth. That's your criteria. So you would measure that in 2 places or 3 places along the top of the flow sensor to make sure that it's in the right location. The same is done for a duct blaster fan, but that one we have is about a 1/2 inch for the pressure sensor, or for the location from the edge of the fan housing to the motor, and it's measured against the motor itself. So it's measured against the motor itself. So we don't talk about the flow sensor, because the flow sensor is fixed and screwed to the back of the motor, so you can't adjust the flow sensor back and forth. It's strictly a situation with the motor, so we just want to make sure that it's tight. Because the motor of the duct blaster fan is lighter, it doesn't have as much inertial force when it gets dropped like a blower door fan. So that's the quick and easy of how to check the flow position sensor and how to check the leak on the duct blaster fan. And with that, we are now at our endpoint of the webinar, and look to see if there's any questions that you might have. There were a couple of questions. One came up concerning whether the Energy Conservatory offers the calibration equipment to do a full calibration elsewhere. And the answer to that is no. We perform multi-point calibration that is done with computer connections. The sensor itself is changed with our computer algorithms. The Menser calibration device is roughly $5,000 alone. So it's not something that the average person is going to want to get out in the field along with a dedicated set of equipment in order to do that calibration. We are also asked to repeat the email address for the BPIs. You want to make sure that you send it to editor@energyconservatory.com, and then we will make sure that your BPI numbers are added to this webinar. And then Paul's joined me. Is there any questions that have come up that you think might be useful?
Well, another question that we got from a couple of different people were related to storing the DG700 when you're not using it, and what we recommend for storage and how that might affect calibration. And we do recommend that, especially in extreme temperatures. We're in Minneapolis, so when it's below zero, you wouldn't want to leave any electronic equipment outside overnight. But the same would be true if you have it in a car that's in the sun. You can get up to 120 degrees in there pretty easily. So any electronic equipment, we recommend bringing in overnight for sure, and even when you're not using it, bring it into the office. So if you have one bag that contains all your electronics and bring that in overnight, that's always a good idea. And we don't, our customers don't provide us with that kind of data on how they store their gauges, so we don't have any data that supports how that might affect calibration. And generally speaking, it's our opinion that gauges drift over time. That's what the data shows, and we suspect it has more to do with time than it does with amount of use. So things that cause a gauge to go out of calibration are specific to that particular gauge, and some will drift more than others. I think that's about it. Those are the questions we had during the webinar.
Yeah, and I just thought of another one that that comes up. One of the things that we do when we get a gauge back for calibration is we open up the back of the gauge. And one of the things that we see, especially with gauges that have been stored without being used, the key there is not being used, is that the batteries that are kept inside the case will have a tendency to leak, especially with very cheap batteries. When we send out your gauge, we have Panasonic industrial grade AA batteries that go in the DG700, and we know them because of their ability to not leak over time. If you use off-brand batteries that you might not be familiar with, or store-brand batteries, chances are those can leak. And what happens is that the leak of the battery acid will migrate to one of the connections, either for the touchpad, or migrate, if it's done, if it's left over time, can go to the digital gauge board. And in order for us to, sometimes we're able to save it before it gets too bad, where we're able to clean off the corrosion on the board, and we want to make sure that we want to help ensure that your gauge lasts as long as possible. So we don't want you to use really cheap batteries and then put them in and just leave it for 2 or 3 months. That's not going to do your gauge any good, and you'll just get a repair bill from us instead of just a calibration. You'll get repair and calibration. So we want to make sure that you're using the good quality batteries. And we know that even with the off-brand batteries, as long as you're using it on a regular basis of a couple of times a week at least, then the batteries, the activity of the battery is worthwhile. Now, we do also see sometimes when the touchpad becomes unresponsive, and there are times when we've seen that where it is this battery leakage that affects the terminal connection. So when we see that, then we need to have the gauge back for repair and recalibration. Let's see, was there something else?
The other thing I wanted to stress again is using the TechLog 3 software when you're doing this. You can see that it's really a powerful software, and there are certainly other uses for it for data logging and doing multi-fan tests. But for this application, I think it fits really well. And we do have a video clip that'll be on a link to it on our website that goes into more detail on how to do this calibration check, how to configure, to go through the configuration settings, and a little more in depth. It's about 25 minutes long, I think, that guides you through using that TechLog 3 software to do this field calibration check. And then you've got a great record of what date you did the test, and it's a confirmation that the gauge you're comparing it against was recently calibrated, and also you've got a time average of a 10-second average or a 20-second average, whatever you want to, however long you want to make that period, and you've got that data for each of those data points.
We just had another question come in regarding the calibration tag on the back of the instrument, and that a QA, QC technician saw that the gauge on the contractor's, the gauge of the contractor had no calibration sticker on the back. that would be really unusual that would happen. And we can look up the last time it was calibrated, and if it was certainly within the last 10 years, we should be able to provide a copy of the last calibration sticker or calibration data that was done. You can sometimes find the gauge serial number inside the battery compartment. And if it's not there, it is written on the inside of the gauge, which you'd have to take the gauge apart to actually find that. So that would be a more difficult process. But if you do have the serial number, we can look it up. But I would think that if the calibration sticker was taken off the gauge, chances are it's because they don't want to show when the last time it was calibrated. So,
but you know, one way, if you're missing that sticker and you want to know what the calibration date is, our TechLog 3 software is free, and you click a button that says, you know, does a search for gauges, and it'll list what the serial number of that gauge is. And then you'll also be able to, you know, the software will, after you've done a recording, after you've done a short recording, once you start the recording, you can look up under that tab like I showed it in the software, you can look up what the last factor calibration date is. So there's a way to get at that information, both the serial number and the last calibration date through that TechLog 3 software.
Another question was, can a loose hose connection be fixed inside the gauges? Yes, absolutely. They can be done. We do that fairly frequently. Certainly, you know, we would not recommend you go inside the case, but it can be done. And sometimes with the action of taking the hose on and off the barb, sometimes that will get loose. There is a screw behind, or the pressure tap is a screw, and it has a nut behind the case that keeps it in place, and sometimes that can get loose. So you can open up the back of the gauge and tighten up that pressure port, and as well as reconnect a loose connection. The kind of two questions combined. One was, when will the DG1000 be available? We're hoping that it should be this summer. Still a couple of months away, but it's looking really good. Related to that then is, will the DG700s continue to be both manufactured and repaired? We have enough parts for DG700s to be manufactured for about 2 years. After that, it will allow us to have enough parts on hand to be able to do repairs and recalibrations. So we intend that the DG700 will be repaired and recalibrated well into the future. DG3s, we're getting to the point where we're actually running out of a number of parts. So if someone sends in a DG3, the last time we manufactured a DG3 was about 13 or 14 years ago. So if someone's has a part that's broken or missing on a DG3, very soon it might not be repairable. So just as just a word of caution to those that might still actually have those gauges. And we know that they're out there because we do calibrate them frequently. So.
One other comment I had is, if you're doing this field calibration check and the pressures aren't stable, double check your tubing to make sure that you don't have leaks in your tubing. But if the tubing all looks solid, it may be an internal leak on one of the gauges. Either probably not the one that just came back from calibration, because we would have found that, but it may be the case in one of the gauges that you're doing a comparison against. And if you run across a gauge like that, that will need to be sent in for repair.
And it could be, that could also be the indication of an auto zero valve failing. That's a pretty rare occurrence, but an auto zero valve can go out, and that would cause a permanent leak as well. So I think that's it. We're 15 minutes over our time. We hope this has been useful for you. Again, if you need to review something, it'll be on our website soon, and you can be able to look at that and review that and share that with others that you work with. And again, also send in your information about webinars that you would like to see. Either send them in directly to editor@energyconservatory.com or to Paul or myself. Thank you very much, and hope you have a great rest of your day. Thanks.